So hello everyone, my name is Riccardo Trevisan. I'm a PhD student at the University of Cagliari, and I'm going to talk about the economic benefits and redistribution methodology that we developed for the renewable energy communities. Why it's not going forward? Okay. This is the summary of the presentation. I'll start with a brief introduction, then I'll introduce the methodology, then we'll take a look a little bit of the mathematical formulation, and then I'll introduce some case studies, and then finally we'll talk about some conclusions. So I guess that by now all of you will know what renewable energy communities are, but again, they are an innovative model for production, distribution, and consumption of renewable energy at the local level. They must be formed as a legal entity, such as cooperative societies, associations, consortium, and so on. They are autonomous and controlled by the members of the community, and they are open to the participation of public entities, private citizens, and businesses. The objective is not to generate financial profits, but rather to provide environmental, economical, and social benefits. The Italian regulator defined an incentivization system for the diffusion of renewable energy communities, which is composed of feed-in tariff and an incentive for the shared energy. Shared energy is defined as the minimum over an hour between the energy withdrawn from and fed into the grid. This same very amount is also subjected to the restitution of the system charges. So about the methodology, our objective is to define a meritocratic revenue sharing mechanism among the renewable energy community members. And to do so, we categorized the revenues into categories and divided the users into classes. Classes are consumer, prosumer, and producer. And the category for redistribution are illustrated here in the redistribution tree. But let's just focus on the leaf nodes. These in the leaf nodes are located the quantities that can be actually redistributed among the members, except for the category which is called provisions, because of provisions. And with this model, we can realize and adapt it to different cases and scenarios. Each user is then allocated the quantities that are taken from categories, and the participation of a user to a certain category can be defined at will. The amount allocated to each user is proportionate to some statistical data based on their withdrawn and the energy fed that gets fed into the grid by the user themselves, such as, for example, the formulas that are reported here. So we want to calculate the total incentive for each user, and we modeled a mixed integer linear optimization problem. You can see the definition of the system here, where in the URA, the elements of the URA contains the total incentive allocated to the ETH user. The QRA, which is of the same length of the leaf nodes, contains the quantities allocated into the redistribution categories, whilst in the matrix, its elements are the ratios that were introduced earlier. Whilst in the formula on the bottom, it's just a formula to calculate totally allocated incentive within the community. We wanted also to introduce a metric of equality, basically. Let's focus on the formula on the bottom. The first member, the part on the left, is basically the total benefit for the ETH user. This total quantity must be greater than a percentage of the incurred costs for the energy expenditure, for instance. It can be defined based on whatever we want. Of the case studies, we simulated energy communities for the period of 1 year, which is composed of one producer, two consumers, and two prosumers. These are the parameters that we calculated after the simulations. So you can see the percentages that relate to the image matrix, as well as the cost and the revenues generated by the feed-in tariffs. We ran 5 simulations with different objective functions and constraints. The first simulation, in first with simulation 1 to maximize the allocation of the incentive, so no quantities allocated to the reserve category. And we also want to achieve a minimum of 10% for cost reduction for all the users. In the second and third simulations, the objective function is the same, it's just formulated differently. And the cost reduction, we want to achieve a cost reduction of 10% in simulation 2 and 5% in simulation 3. Whilst in simulation 4, we want to maximize the cost reduction for the prosumer users, which are the user number 2 and number 4, while also achieving a cost reduction, a minimum cost reduction of 10% for all the users. In simulation 5, we are trying to maximize the cost reduction for the prosumers, for the producer, sorry, with a minimum cost reduction of 8% for all the users. These tables reported the results. In the table above, we can see the quantities that are actually allocated in the redistribution categories that we defined earlier. And in the second table is the user percentage cost reduction achieved in various simulations. So in simulation 1, we achieved the maximum average cost reduction. We can see also that the category 4 is never used, and category 8 and 9 are used only when incentive for producers and prosumers are required to be maximized. Also, producers and prosumers benefit from a higher percentage cost reduction thanks to the feed-in tariff. So in conclusion, we defined a methodology for the distribution of economic benefits based on meritocratic and equality principles, which proves to be flexible, effective, and can be easily generalized to different case scenarios. And future developments might regard to extend the model with other parameters that makes the possibility to consider a broader community context, and also to test other softwares and algorithms for solving such problems, since we use the modeling language, which is called MEDPOWER, just fast for deploying, and you gave us this opportunity. Thanks for the
Thank you very much, Mr. Riccardo. Any questions?
It's not actually a question, it's more on the last slide where it was the discussion about the future work. But maybe, I mean, an extension towards coalition formation and how this can be extended in some kind of cooperative game theory. So, which is the optimal remuneration or incentive that can drive kind of the formation to the local community level.
The theoretical optimal, I think that it's a theoretical optimal. This is based on actual simulated data, and it's kind of different, but it can also be the theoretical optimum can be helpful to define how to reach this. It can be helpful to define how to reach it. So yeah, for the suggestion.
Any other questions? Okay, so what do you think that obviously you have tested it, you have simulated this up to this particular community context? How does this relate to other existing methods that carry out the same type of analysis?
For redistributing economical benefits within members? Well, none of the that I know of, the methodologies that I've seen are based on meritocratic and equity principles. So this is the
Do you see some drawbacks with regards to, are you expecting to find some difficulties when you apply this with more specialized softwares in the future?
But we'll see if we will face some new challenges. But generally, we have to define to identify new algorithms to solve it more efficiently. So this model that we have, or algorithm that we actually use, is quite limiting. Also, in the moment when we define a wider community with more members, this software is for sure limiting. So future algorithms must be taking this issue.
That's it. Thank you very much. Thank you.